let's look at distance between two points in 3D space. So let's say we have 2 points P, let's say x1, y1 and z1, and Q, x2, y2, z2. Now their corresponding position vectors would be OP equal to x1i plus y1j plus z1k, and OQ would be x2i plus y2j plus z2k. Now let's say this is P, this is Q, and this is O. So this is our position vector OP, this is position vector OQ, then this would be our distance between the two vectors PQ. So PQ is equal to OQ minus OP. Okay, so x2i plus y2j plus z2k minus x1i plus y1j plus z1k. Now let's take the i's, j's and k's together. So x2 minus x1i plus y2 minus y1j plus z2 minus z1k. And we know also that the magnitude of a vector is equal to the square root of the sum of the squares of the resolved parts. So x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this is the distance between 2 points in space. In particular, let's say one of the points is at the origin. So let's say P x comma y comma z is equal to P 0 comma 0 comma 0. In which case what happens? PQ would be equal to, you can take any one of them, whether x2, y2, z2 as 0 or x1, y1, z1 as 0. So you will end up with x2 square plus y2 square plus z2 square, or in general PQ would be equal to x square plus y square plus z square, and this is what we had seen earlier. Now let's look at some additional aspects. Now let's say we are given 3 points A, B and C. What we want to figure out is whether they are collinear or not. So collinearity we have to figure out. That means, do they fall on the same line in 3D space? So for this, AB plus BC is equal to AC. Remember, here when we talk of AB, we are talking of the magnitude of the vector AB. So magnitude of the vector AB can be written as AB. Okay, and if this could happen in any particular order. So AB plus BC equal to AC, or AB plus AC equal to BC, or AC plus BC is equal to AB. If any one of these conditions are true, then the points are collinear. Okay. Now vertices of a quadrilateral, right? So here we looked at collinearity, vertices of a quadrilateral. Again we have 4 points A, B, C, D. AB equal to BC equal to CD equal to AD. That means what? Sides are equal. Now, if AC is equal to BD, that means what? Diagonals are equal. Therefore, parallelogram. All the sides are equal and the diagonals are equal. Now, if AC is not equal to BD, that means diagonals are not equal, therefore a rhombus. So now to figure out what type of figure it is, you have to know high school geometry. This is very important. Now let's look at locus, set of locations basically. Locus means set of locations of something. Locus of the point equidistant from 2 points, right? So let's look at this aspect. Let's say we have A, x1, y1 and z1, and B, x2, y2, z2. Now what we are talking of is, let's say one of the points is, there is a point on the locus is px comma y comma z. It's a point on the locus. So it is given that PA equal to PB. So therefore square root of x minus x1 square plus y minus y1 square plus z minus z1 square is equal to x minus x2 square plus y minus y2 square plus z minus z2 square. Now simplify the above to get an equation for the locus of the point equidistant from A and B. Okay, let's look at locus of the point which moves such that its distance from x-axis is twice its distance from yz plane. Right? Don't get confused. Distance of P, let's say P is that point, a point on the locus. Distance of P from x-axis is going to be y square plus z square. Okay, distance of P from yz plane is nothing but x. Yes, and we are given that the distance of P from x-axis, that is y square plus z square square root, is twice the distance from yz plane. Now it's just a question of simplifying it. Take the square root on both the sides, square both the sides, 4x square. Okay, I think you got the idea. Bye for now.